I used to think the gap between our industrial capabilities and Japan's was at most about 10 years. But once again, reality has changed my perception. This is a high-precision grinding machine from Japan, one that is banned from being sold to us. It comes from a small workshop with fewer than 200 workers. It was manufactured as far back as the 1990s. At a time when many people were still struggling to get enough food, their grinding machines were already using a full hydrostatic 3-axis system. The XY axis is fully hydrostatic, achieving a flatness of 0.5 microns over a surface of 1 meter by 700 millimeters. The vertical axis maintains constant hydrostatic pressure to counteract the effects of gravity, allowing a feeding accuracy of 0.1 microns. To this day, we have not been able to break through this technology.
日本机床实力有多强？
How advanced is Japan's machine tool industry? Their high-end machine tool spindles can reach speeds up to 40,000 rounds per minute. In comparison, our machine tools only reach about 10,000 rounds per minute. That's the difference.
这玩意儿呢，有几十台。
Take this piece of equipment. There are dozens of them. It's called the CNC Machining Center, and it's extremely advanced. So far, we haven't been able to develop it ourselves, yet in Japan, it's already considered outdated. Recent discussions online suggest that China's machine tool industry lags 50 years behind Europe, the United States, and Japan. While this claim may seem exaggerated, comparative data indicates a significant gap. In the 1990s, small workshops in Japan were already ahead of China, a country recognized for its manufacturing capabilities. The spindle speed of Chinese machine tools is only a quarter of that in other countries. In the field of advanced CNC machine tools, China has yet to develop its own version, while other countries have already introduced newer generations. This disparity has led to frequent online discussions about China's machine tool industry. Two commonly cited arguments are the manufacturing collapse theory, which suggests that if China loses access to foreign machine tools, its manufacturing sector would struggle, and the defense collapse theory, which argues that without Japanese machine tools, China would face challenges in producing aircraft carriers and fighter jets. Machine tools, often referred to as the mother of industry, are considered a critical foundation of manufacturing. They are essential in industries ranging from aerospace and automotive production to precision instruments and military equipment. The performance of machine tools directly affects the quality and technological level of manufactured products. China claims to be the world's largest producer of machine tools, leading in both production volume and total output value. At first glance, this seems impressive, but a closer look reveals a different reality. Just like China's broader manufacturing industry, its strength lies in the low-end segment, while high-end production is firmly controlled by Europe, the US, and Japan. According to Chinese state media, domestically produced machine tools account for 82% of the low-end market, 65% of the mid-range market, but less than 10% of the high-end market. Some estimates say it's as low as 6%, meaning 90% of high-end machine tools have to be imported. This is especially true for advanced machines used to manufacture jet engine components, microcircuit board elements, and other cutting-edge products, which are supplied by companies from Europe, Japan, and the US. Looking at key performance indicators, the gap between China's machine tools and those from Europe, the US, and Japan is enormous, with a lag of nearly 50 years. First, in terms of precision and reliability, the difference is staggering. For example, Germany's Waldrich Coburg produces gantry machining centers that maintain 95% precision even after a decade of use. In contrast, 80% of new Chinese equipment struggles to meet precision standards from the start. Additionally, China relies almost entirely on imported precision measuring instruments. If measurements aren't accurate, producing high-precision machine tools becomes nearly impossible. When it comes to the average mean time between failures for CNC systems, foreign systems typically last 30,000 hours, while Chinese systems average only 10,000 hours. In other words, their lifespan is only a third of their foreign counterparts, making it difficult to compete. Second, in terms of materials and high temperature resistance, China is also far behind. High-end manufacturing isn't just about precision, it also requires heat and wear resistance. One reason US fighter jet engines last so long is their superior blade material composition, which blends multiple elements like an advanced form of alchemy. These engines can operate under extreme conditions for tens of thousands of hours without issues. In contrast, China's J-20 fighter jets initially relied on Russia's AL-31 engines. As for heat-resistant materials, China isn't just lacking the right formulas, it doesn't even have a full understanding of the chemical composition. One commenter joked, quote, "Knowing the ingredients is useless. If the ratio is wrong, the result is just scrap metal," unquote. The third major challenge is CNC systems, often referred to as the brain of machine tools. In the mid to high-end market, the industry is dominated by overseas manufacturers. Among the world's top 10 CNC system brands, only one is from China, and it operates in the lower-end segment. China faces significant gaps in both hardware and software for manufacturing and operating high-precision CNC machines. This sector has long been led by Germany's Siemens and Japan's Fanuc. Along with Mitsubishi, these three companies control 2/3 of the Chinese market. Siemens holds 33%, Fanuc 20%, and Mitsubishi 16%. In contrast, all Chinese CNC systems combined account for less than 30% of the market, with performance and reliability that fall short of global standards. Another critical component of machine tools is the hydraulic system, and in the mid to high-end segment, China remains heavily reliant on imports. This dependence not only drives up production costs, but also leaves Chinese manufacturers exposed to risks from international trade restrictions and technology controls. Some suggest that since China is well known for leapfrogging industries, it should simply buy advanced machines and reverse engineer them. While this may work for some products, high-end machine tools are a different story. Overseas manufacturers have long anticipated this and have built in strict security measures to prevent it. How can we possibly overtake them? A high-precision machine tool that costs tens of millions only grants the user operating rights. Moving it requires unlocking, launching the software requires unlocking, everything requires unlocking. Essentially, spending tens of millions only gets you a leased machine, and even then, you still have to wait in line to buy it, because if you can't make it yourself, you have no choice but to buy from them. This is not an exaggeration. Many domestic factories that purchase high-precision machines from Germany, Switzerland, and Japan face the same situation. A machine that costs 30 million requires an additional 3 million just to hire foreign technicians for installation. You heard that right, the installation fee alone costs several million. And during the installation process, no one is allowed to observe or even enter the workshop. Since the manufacturers install the machines themselves, if anything goes wrong during use, only they can repair it. According to one industry insider, manufacturers limit how machine tools can be used to ensure precision. Many come with built-in locators, gyroscopes, and restriction systems. Some machines will lock if moved even a single meter, rendering them useless without the manufacturer's decryption key. Others have built-in software locks, requiring companies to purchase expensive activation keys to produce new parts. Each unlocking code is unique, making unauthorized replication nearly impossible. In short, there are no shortcuts for China in high-end machine tools. One woman who imports second-hand equipment also pointed out another reason why China's leapfrogging strategy won't work.
Why do people say that even if we spend another 30 years, we still won't be able to make the machine tools that developed countries had 10 years ago? This German-made Hermel machine from the past decade might provide an answer. In Germany, this kind of machine tool is like the Bentley or Rolls-Royce of the automotive world. For the same machining range, an ordinary brand might sell for 400,000 to 500,000 yuan, but this one sells for 4 to 5 million. The extra millions aren't just for the brand, they are paying for a combination of high speed, high precision, and high rigidity. This machine uses an overhead gantry cradle structure, which allows for more advanced machining capabilities. For the same travel range, most 5-axis machines have a spatial positioning accuracy of about plus minus 50 to 60 microns, but this one achieves just 10 to 20 microns. If we want to reach this level of precision while maintaining both rigidity and speed, it might really take another 30 years. And this is just the foundation that developed countries had 10 years ago. It's not that they only became advanced in recent years. They've been ahead for a long time. While we've made rapid progress in the past few years, when it comes to high-end machine tools, there is no shortcut to catching up.
As a result, China's machine tool industry remains stuck in the low-end market. But the competition there is fierce. Of the world's 140,000 machine tool manufacturers, 23,000 are in China. With China's manufacturing supply chain shifting overseas in recent years, the market has already shrunk, leading to severe overcapacity. The outcome, a brutal price war. Companies fight over low-end market share, slashing prices until they bleed, only to end up destroying their own industry. In 2020, Chinese media outlet Chinese Business Strategy reported that 18 state-owned machine tool enterprises had nearly all collapsed, questioning how this so-called national treasure industry had fallen so far. The answer was simple: chaos in the low-end market, fierce competition in the mid-range, and complete failure in the high-end sector. Companies were struggling to survive in the cracks. Looking at the 2024 industry report, revenue in China's machine tool sector fell by 5.2% to 1 trillion yuan, while profits plunged 77% to 26.5 billion yuan. The official explanation was intensified malicious competition, but in reality, just like many other industries, it all comes down to overcapacity and cutthroat competition. To understand how severe China's low-end competition has become, one second-hand equipment dealer, known as Bao shared a typical case that illustrates the industry's brutal reality. This here is the famous fiber laser cutting machine. 10 years ago, one of these cost around 2 to 3 million yuan. 5 years ago, the price dropped to around 1 million. 3 years ago, it was about 500,000. But today, a brand new one costs just a little over 100,000. In our industry, it's known as the ultimate depreciating machine. Why has the price dropped so fast? The simplest answer is that we've mastered the technology to manufacture it ourselves. According to industry expert Bao, when the first generation of CO2 laser cutting machines emerged around the year 2000, only Germany's Strumpf, Japan's Mitsubishi, and Japan's Fanuc were capable of producing them. These machines were highly expensive at the time. Later, the invention of fiber laser technology by the US-based company IPG made fiber lasers the core component of laser cutting machines, though prices remained high. A major turning point came when China's leading laser equipment company, Hans Laser, acquired a stake in IPG in 2008. This allowed China to gradually gain access to the technology. Once it was introduced to the domestic market, adoption spread rapidly. Other companies such as Wuhan Rakes and Shenzhen Max Photonics also mastered the technology, leading to a sharp decline in laser prices. The frequency of price adjustments increased from once every 6 months to once a month. For example, the price of a 3 kilowatt laser, which once cost over 1 million yuan, has now dropped to around 30,000 yuan. The drop in laser prices also drove down the cost of laser cutting machines. As in other industries, once the market appeared profitable, Chinese companies rushed to invest, leading to the rapid emergence of over 3,000 manufacturers. This triggered intense competition, with prices continuing to fall due to a limited number of buyers. As a result, laser cutting machine prices now decline almost daily. Last year, Bao purchased a second-hand laser cutting machine for 50,000 yuan from a factory that had gone out of business. The estimated market value was over 60,000 yuan, yet he has been unable to sell it, as there is little demand. The machine had originally been bought for over 1 million yuan just 3 years earlier. In other words, in just 3 years, its value depreciated by 95%. Making matters worse, the factory that purchased it never made a profit from the machine and ultimately had to sell it at a massive loss after going out of business. The pace at which customers generate revenue is far slower than the rate at which equipment loses value, a reality that many Chinese manufacturing firms are facing. In the face of fierce competition, laser cutting machine manufacturers have resorted to cutting costs to survive. Machines that once weighed over 10 tons have been reduced to just 700 kilograms. Cast iron frames were replaced with steel plates, which were later switched to steel pipes. As frames became lighter, they started to warp during operation. Laser lenses, which previously had multiple coatings, were downgraded to single-layer coatings and reduced power. Imported rails from Europe and the US were first replaced with Taiwanese-made versions, then ultimately switched to domestic brands. Across the board, components have been downgraded. Bowdern believes that many machine tool manufacturers will be eliminated in the coming industry shakeout, a consequence of severe overcapacity. There are several reasons why China's machine tool industry has reached this point. Analysts point out that machine tool manufacturing is a high-barrier industry that requires technical expertise, specialization, and long-term investment. Companies like Siemens and Fanuc have spent decades focusing on their niche markets, becoming global leaders. In contrast, once Chinese machine tool companies achieve some success, they tend to pursue rapid expansion. Former industry leaders such as Shenyang Machine Tool and Dalian Machine Tool struggled after following this path and eventually found themselves in dire situations. Another major challenge is the shortage of highly skilled technical workers. In Chinese companies, technical personnel often hold low-status positions and face significant career barriers. Many firms are reluctant to invest in developing their workforce, leading to a major talent gap. In contrast, Japan began producing machine tools as early as 1889, becoming the third country in the world to do so, though their technology was not advanced at the time. To catch up, Japan invested heavily in training technical talent. When the United States and Germany were leading the global machine tool industry, the Japanese government sent teams abroad to learn from them. Japan made it a priority to participate in every major industry conference, demonstrating a deep-rooted commitment to advancing its technology. Decades of persistence allowed Japan to secure a dominant position in the high-end machine tool market. By comparison, many Chinese companies prioritize office politics and internal networking over technical expertise. Another factor is government policy. In recent years, the Chinese government has focused its resources on semiconductors, electric vehicles, robotics, military technology, and aerospace, while machine tool industry has been largely overlooked. With the real estate market in decline and local government finances under strain, support for machine tool companies has also dwindled. For an industry already trapped in a cycle of intense competition, this has made survival even more difficult. As investment shifts to these new priorities, machine tool manufacturers have been left to fend for themselves. However, all of these industries still rely on machine tools, which form the foundation of manufacturing and are an essential part of the supply chain. A weak machine tool sector directly impacts the development of downstream industries. When it comes to engine manufacturing, the reason US fighter jet engines lead the world in durability is closely tied to advanced machine tools and material technology. China has not been able to produce high-end engines on its own. The precision machine tools needed for processes like crankshaft machining and cylinder block grinding mostly come from Germany's Niles Simmons or Spain's Extitar. Chinese-made equipment struggles to meet the required standards. This is why early versions of the J-20 fighter jet still relied on Russia's imported AL-31 engine, showing a clear gap compared to the US. In aircraft carrier manufacturing, Japan once claimed that without access to large-scale machine tools, China would not be able to build an aircraft carrier. While China has since developed its own carriers, the production of core components still depends on imported equipment. If geopolitical tensions disrupt the supply chain, maintaining and upgrading these carriers could become a major challenge. As one online commentator noted, a country's strength is not just measured by its military equipment, but by its ability to independently produce those weapons and systems. The Chinese government has been unable to produce its own high-end machine tools and continues to face restrictions. A case from 30 years ago illustrates this issue, with records sourced from the U.S. General Accounting Office and the Department of Commerce. In 1994, McDonnell Douglas planned to set up a factory in China to build 40 MD-82 and MD-90 passenger planes for the Chinese market. Manufacturing aircraft parts required advanced machine tools. At the time, McDonnell Douglas had 19 second-hand machines from a shut-down plant in Ohio, including 10 Cincinnati Millicron machining centers, 2 5-axis machining centers, and coordinate measuring machines. These machines had previously been used to manufacture parts for B-1 bombers, C-7 Globemaster transport planes, and cruise missiles. Despite being in use for more than a decade, the U.S. Department of Commerce remained highly cautious, concerned that if these machines ended up in China, they could be reverse engineered. At that time, these machines were considered the most advanced available in China, and even as second-hand equipment, each was valued at $5 million. In the end, the U.S. Department of Commerce approved the deal but imposed strict conditions. McDonnell Douglas was required to station personnel at the Chinese factory to oversee production and submit reports every 6 months. The machines had to be equipped with monitoring devices that tracked daily usage and the specific parts being processed, with no allowance for additional production. All data had to be regularly reported to both the Department of Commerce and the Department of Defense. A further restriction required the machines to be activated using encryption keys controlled by the Department of Commerce. The message was clear: these machines could only be used to manufacture MD-82 and MD-90 components, with no exceptions. Even with these restrictions in place, the US government remained cautious and reduced the plane production from 40 aircraft to just 20. The review process did not stop with the Department of Commerce. Several U.S. agencies, including the Defense Intelligence Agency, the Central Intelligence Agency, the Defense Technology Security Administration, and the Air Force National Air and Space Intelligence Center, were all involved. Only after passing multiple layers of scrutiny and strict regulations was the deal finally approved. In October 1999, the first China-built MD-90 was assembled in Shanghai and successfully completed its test flight. Behind this process, however, was a high level of US caution, with authorities taking every possible measure to ensure that the machine tools remain tightly controlled. China's 50-year lag in machine tool development is not due to a lack of technical expertise, but rather systemic issues within its industrial structure. The country has not built an environment that supports the development of high-end machine tools, leading to disruptions in the industry's ecosystem. In advanced manufacturing, China remains heavily dependent on the US, Europe, and Japan. Meanwhile, the domestic low-end market follows a familiar pattern: rapid overexpansion, excessive production capacity, and aggressive price competition, ultimately leading to widespread losses. There is no shortcut to catching up. Leading nations have already put up barriers. Falling 50 years behind is not the end of the challenge, it may only be the beginning. Without fundamental changes in strategy, closing the gap could take even longer.